The earliest putative member of the lineage represented today by the clade Anura is from the lower Triassic of northwestern Madagascar, that is about 215 million years ago. Triadobatrachus is represented by a single individual whose rather complete skeleton is preserved as negative impressions in a small nodule split into two parts. The vertebral column had 15 trunk vertebrae, 1 sacral, and at least 10 caudals, according to a recent revision based on CT scan. It was placed on the annular stem because, in black, the absence of teeth of the dentary, slightly elongated iliac shafts, and presence of a frontoparietal in the skull. Also, the metapolials are moderately elongated, among other features. Whether a short tail was visible externally is not possible to determine. The next earliest recorded Salientian is Prosalirus from the Pisbachian of North America after a gap in the fossil record of nearly 70 million years. It consists of fragmentary, partially articulated specimens or isolated bones. Despite this incomplete preservation, it is clear that it had a dramatically different morphology from that of Triadobatrachus. Its morphotype being closer to that of frogs. The total number of vertebrae is unknown, but the sacral vertebra has a narrow neurolaminae without paucizygopophysis, and this suggests that an urostyle was present. The ilium has an elongated shaft, and radio and ulna are now fused. In turn, the Toarcian alien Vierella is from southern Patagonia. A single individual is known preserved as ventral and dorsal impressions. According to poorly ossified, it is post-metamorphic because of the already ossified carpus and digits, and also posterior medial processes of the hyoid. The total number of presacral vertebrae is unknown, although it might have had about 10. A urostyle was already present. And this is the interpretation of the dorsal impression. Also, one question is if Vierella, as well as Prosalirus, are already members of the crown Anura, the clade that includes all living frogs. Are they already related to the most basal frogs living today? In fact, their distribution in Arizona and southern Patagonia mimics the relictual distribution of Ascaphus and Leiopelma, one in North America Scaphus, and Leiopelma being endemic to New Zealand. But Mirella and Procellaris are really poorly represented. So in order to analyze the evolution of anurans, or frogs in fact, let's turn to the best preserved Jurassic frog, also from Patagonia, that is Notobatrachus digistoi. The abundant impressions of this large frog, that has an adult length between 9 and 15 centimeters, occur in several localities in southern Patagonia. Most specimens consist of the impressions of the articulated skeleton. Radiometric dating of volcanic rocks that are interbedded with the frog-bearing tuffs have ages that resulted in an isochron of about 168.2 million years, that is a Calovian Oxfordian age. The abundance of specimens in a single locality permits the analysis of ontogenetic, sorry, I need some light, if it's not here. Sorry. Not this one. Is it? Oh, that's why. Okay, now yes, it's better. Thank you. Sorry. So, okay, these are latest cast of Notobatrachus, of course, adult specimens. But the abundance of specimens in a single locality really permits the analysis of ontogenetic variation, unlike the case of all other known Jurassic salientians. In Notobatrachus digistoi, most dermal skull bones are ornamented with patches of well-defined ridges and grooves. However, the neurocranium was mostly cartilaginous, and the sphenethmoi remained paired throughout life, unlike that of Procellaris and Palaeontologists. That's something that also occurs in Scaphus and Leiopelma, the most basal living frogs. The presence of 4 or 5 pairs of ribs is a plesiomorphic character of Notobatrachus. Also, it is common the presence of a complete post-sacral vertebra with a sacral vertebra that looks like all the other presacrals and also has post-zygapophysis to articulate with the urostyle. As in Procellaris, another plesiomorphic feature, the premaxilla bears an alary process located medially. So you see here the medial position of the alary processes and the pair sphenethmoi that remains paired all life of individuals. So it's only fused in really very old specimens, really large specimens, but it is usually paired as it occurs, as I said, in basal living frogs. Ontogenetic variation is also evident in the shape of the skull, being longer than wide and having a pointed snout in young specimens, whereas in adults it is broadly rounded. Teeth are not pedicellate, as in Scaphus also, but also this feature occurs in Xenopus and Palaeobatrachians, all aquatic frogs. This is probably a metamorphosing individual. It lacks the sphenethmoid that is still anossified. What you see through the separation between both frontoparietals is the dorsal aspect of the parasphenoid that is on the ventral side of the skull, of course. Also, you can see the vertebra that the dorsal neural arches are still paired, they are not fused. And there is something interesting here, and is that you can see the development of the ribs, usually in an anterior to posterior direction as in alpha. Of course, also the carpus is still anossified. In fact, the other one was the only specimen that we have that is really metamorphosing individual. We haven't recorded any tadpoles or notometapus, despite the high number of specimens that we collected, more than 100. So this is the restoration of the complete skeleton. Of course, the pectoral heel is not there. And these are aspects of the skull in dorsal and ventral views. In the last 10 years, paleontological prospection was conducted by researchers of several institutions in the Cañadón Asfalto Basin. This basin is located in central Patagonia, south of the North Patagonian Massif. The basin was formed by a rift system that developed linked with the mechanism of Gondwana disintegration, with several depocenters in which continental, Jurassic, and Cretaceous deposits of fluvial, lacustrine, and volcanic origin were accumulated. The successions that represent the initial phase of continental rifting comprise 3 stratigraphic units. The upper 2 highly fossiliferous and with indications that the deposition occurred in high relief volcanic environments. The lower unit, La Leonera's Formation, consists of fluvial channel sandstones, floodplain mudstones, and lacustrine tuffs. They are followed by the volcanic deposits of the Longo-Trapial Formation associated with the interplate volcanics due to the opening of the Weddell Sea. The overlying Cañadón Asfalto Formation has a lower section characterized by the presence of basaltic flows and tuffs intercalated with fossiliferous pellets of lacustrine origin. These pellets have yielded abundant fossils in the area of Cerro Condor, including a diverse flora of ferns, conifers, and pteridosperms, as well as remains of turtles, sauropod and theropod dinosaurs, basal mammals, together with those of anurans, whom I will refer to shortly. It is the most diverse and well-known document of a Jurassic Gondwana biota. Fossiliferous sites have been discovered in several canyons formed by the drainage system of the Chubut River. Those bearing anuran remains so far discovered are Queso Rayado, Cita Rosa, and Fregueli. Their mutual stratigraphic relationships remain contentious. However, precise radiometric dating of rocks with good stratigraphic control have revealed a more reliable chronological framework to analyze patterns of biological evolution. In this regard, UPV dating of circles near the base of Long Quatrepian Formation place a maximum age of 180 million years for this formation. In turn, samples from about 10 meters above the Fregueli fossiliferous level gave an age 178 million years, that is to Archen. So placing a maximum age for the initial deposition of the Cañadona Falso Formation. So the fossiliferous levels of the Fregueli site are mainly Toarcian now. The most interesting discovery is the material from Cintarossa site. The articulated carcass of a Notobatrachus-like form on the left, above, shows fewer elements than some adults of Notobatrachus dejustoi on the left below, suggesting their cynostotic fusion after the end of the metamorphosis. In fact, this high number of discrete bony carpal elements lends support to the complex origin of the radiale ulnare, an element E that was proposed according to the number of centers of codifications in living anurans. And that feature appears during the development of the carcass. So the material collected in other sites are in fact isolated bones that are being prepared and their study ongoing. Probably this is probably another new taxon. This is a scapula of a Notobatrachus-like specimen from Queso Aliado, and there's an isolated vertebrae, probably an anterior one. So what we can say that is that the molecular estimates of the time of the deep diversion of both lineages within Llanura clay place these cladogenetic events throughout the Triassic. In fact, the paleontological record is in general consistent with this, but few frogs have been described from Jurassic rocks. Moreover, these geographically widespread records do not belong to Crown group representatives, according at least to the phylogenetic positions retrieved in the most recent analysis. Most are already frogs, but not anurans. The anuran bowplant had evolved by then, persisted throughout practically all their evolutionary history. The significant records in Patagonia extend the stratigraphical range of the genus Notobatrachus, which persisted in water bodies associated with volcanic environments for 20 million years. However, the fossil record permits us to make few assertions about the evolution of frogs in the Jurassic. We do not know that by the mid-Cretaceous, we only know, in fact, and it's clear that by the mid-Cretaceous, the differentiation of the main lineages of the Crown group had taken place. Thank you.